Hello everybody and welcome to another tutorial on sorting. So in this lesson we'll be studying selection sort, and to explain the procedure of selection sort I'll be referring to this article on available at geeksforgeeks.org on selection sort, and I'll be leaving a link for this article in your description. So let us study the definition of selection sort. First of all, it says that the selection sort algorithm sorts an array by repeatedly finding the minimum element considering ascending order from the unsorted part and putting it at the beginning. The algorithm maintains two subarrays in a given array, the subarray which is already sorted and the remaining subarray which is unsorted. So like in the previous example on bubble sort, here the algorithm maintains two subarrays, that is one of the subarrays which is already sorted and the remaining subarray which is unsorted. Okay, so at every so after each iteration, in every iteration of selection sort, the minimum element considering ascending order from the unsorted subarray is picked and moved to the sorted subarray. So like in the previous example of bubble sort, we had seen that here what was happening, the highest number at each iteration, it was moving to the end of the list, and this constituted the sorted part of the subarray, and the remaining numbers which had not moved to the moved to their appropriate positions, those numbers which were considered to be out of order, those numbers constituted the unsorted part of the subarray. So this array was divided into two parts, the sorted part and the unsorted part. Something similar is happening in case of selection sort as well. The algorithm divides the entire array into two parts. The first subarray, which is already sorted, first of all it is the one which is already sorted, and the remaining portion of the array which consists of the unsorted numbers, it constitutes the unsorted part. And in each iteration the minimum element from the unsorted subarray is picked and moved to the sorted subarray. So the minimum number, so let us, if we take this array as an example, 80, 32, 31, 110, 50, 40 and so on. So here this example was for bubble sort, but if we take the case of selection sort, what happens here is that the minimum number out of all these in each iteration will be taken and it will be moved to the beginning of the list. So here what will happen is that 31 will move to the beginning of the list. So this will come to the beginning, and this will form the sorted part of the subarray. Alright, and this 31 will be removed from further consideration in subsequent steps. So let us take a look at the example. So here we have an array consisting of 5 numbers, 64, 25, 12, 22 and 11, and at the very beginning we can see that these numbers are out of order. So we need to arrange them. If we are told to arrange all the numbers in ascending order, we'll need to apply some kind of a sorting algorithm, and here they have employed the selection sort algorithm. So let us study the example and find out how it works. So first of all, this 64, which is the minimum number, 64, the position of 64, that is the current element, is taken as the minimum number, and our task is to find any other number which is lower than 64. So after we traverse through the remaining elements, we can see that 25, then 12, then 22 and 11, all of them are lower than 64. So we'll pick the number which is the lowest out of all these. So initially we take 64, that is the current element, that is the one that is being pointed to by our loop. So the loop is pointing first. When the loop executes for the first time, it starts from 0 and it points to 64, because that is the number at the very beginning of the array. And we will take this number, we will assume that this is the minimum number out of all the numbers present in the list. Even though this is not actually the minimum number, we will assume it to be the minimum number. And then we will traverse through the list and find any number which is lower than 64. And then we'll take that number and we'll choose them as the minimum number. So first of all 25 is selected because it is lower than 64. Then 12 is selected because 12 is lower than 25. Then we go to 22, but 22 but the current minimum element, which is 12, it is lower than 22, so we will not consider 22 to be the minimum number. And then 11 is selected because 11 is even lower than 12. So finally, like this, we went through the remaining numbers in the list and we picked the number which is the lowest out of all these, and we moved the number to the beginning. Alright, so this number, it forms the sorted sublist, and we will be excluding it from further comparisons. So now the next time the loop starts from 12. Alright, so 12 is selected as the current minimum number, and then we try to traverse to the remaining elements and we find any number which is lower than 12, but here you can see that there is no number which is lower than 12. So 12, sorry, I made a mistake. So in the next step we'll be starting from 25, and 25 will be considered to be the minimum number, and in this round we'll be traversing through the remaining elements, that is from 12 to 64, and we'll be finding any number which is lower than 25. So here obviously 12 will be the minimum number. So the positions of 12 and positions of 25, they are interchanged. So like in the beginning, what had happened, 11 had gone to 64's place and 64 had been moved to 11's place. So something similar is happening in this case. We are starting the loop from 25 and we are searching for any number which is lower than 25. So we are finding 12. First of all, we are finding 12, which is the minimum number, and so the current minimum element becomes 12. Then we compare 12 to 22, but 22 is bigger than 12 and so is 64. So 12 is, we can understand that 12 is the minimum number out of the remaining numbers. So 12 goes to 25's place in this round and 25 comes to 12's place. And now in the next step, these 11 and 12, these two numbers are already in the sorted subarray. So the numbers that are present in the sorted subarray, we do not need to include them in further iterations of the selection sort algorithm. So in the next subsequent steps, what we are going to do is we are going to start the loop from 22. So we will assume that 22 is the current minimum number, and we will traverse the remaining elements of the array. We will go through the remaining elements 25 and 64. These are the only two remaining numbers, and we'll attempt to find any number which is even lower than 22, but here there are no numbers available which are lower than 22. So the 22 will remain at its proper place and will not be changing it. And after that, something similar will happen to 25, because 25 is also at its proper place. 25 will be considered to be the next minimum element, and we will go through the remaining element, which is 64, and we will not be able to find any number which is lower than 25. So 25 will remain at its current place, and after that we'll be going over to 64, and this is also at its proper place. So this loop has finished. This loop has already completed its job, and it has sorted the list of numbers using selection sort, and this is the resultant array after sorting. So you can see that all the numbers have been arranged properly in accordance to ascending order. Alright, so now let us take a look at the program code for selection sort. So like in the previous example on bubble sort, we are using a switch case like structure to give the user two options. One is to perform selection sort on the given array, and the other one is to exit the program. So when the user selects the option 1, when he enters the number 1 using switch case, we move on to case number 1, and here we perform the sorting. So here we have this OPT. OPT is the variable on the basis of which this switch case is occurring. So the user's choice, the choice entered by the user, that is either 1 or 2, it is stored in OPT, and on the basis of the value of OPT, this case 1 and case 2 this switching is occurring between case 1 and case 2. So if the value of OPT is 1, it goes to case 1, and if it is 2, it goes to case 2. And if the user enters any value other than 1 and 2, nothing is going to happen. Alright, because there is no other case is available inside this switch case construct. So here we have OPT A20, which is the array of numbers which is going to be sorted, and n represents the maximum number of elements will be considering for sorting at any given time. So we'll be entering the length of the array, which is n, and after that we'll be calling this input array function. So there are 4 functions like in the previous example. The first one is input array, which takes the array itself, that is A, and the number of elements of the array as parameters, and here using this function we'll be entering numbers into this array. We'll be accepting all numbers into the array. So initially the array is empty, there are no numbers in the array. So before we can actually execute this sorting, we'll have to provide some numbers into the array, and that is being done using this input array function. And after performing this giving the input, it is printing the unsorted array. So before we are actually going to perform the sorting, we'll have to print the unsorted array and see what it looks like, so that we can get some idea of how the elements are rearranged and sorted properly after selection sort occurs. So here we are calling this print unsorted array function, and it is also taking the array element itself, the array itself as the parameter, followed by the total number of elements that will be providing to the array at any given time. So here it is going through it is traversing through the array, and it is printing all the numbers of the array. And these numbers are these are unsorted numbers. Alright, so these are in the sequence as they had been entered by the user. So these numbers have not yet been sorted. So these are the unsorted array. So this represents the unsorted array. So this function print unsorted array int A20 int n, the task of this function is to print the array before the sorting takes place. Alright, so that we can get some idea of how the array initially looked like, and how it gets changed after the selection sort algorithm is applied to it. And after this we'll have to invoke the selection sort method. So after we invoke this selection sort method or function, it also takes the array itself and the number of elements that we have entered into the array as parameters. And here inside this function you can see that there are 2 variables have been declared, local variables. Sorry, one of them is min and another one is min posts. So we are starting a for loop that starts from 0 and it goes up to n-1, and we are assuming that the element that is being pointed to by this I, it is the current minimum element, and we are also recording its position in min pos. So if the current minimum element is AI, its position, that is its index number, is being stored in min pos. And after that we are starting from I plus 1 or I, and we are traversing to the remaining elements of the array. So let me make it I plus 1. So after we are assigning the current element to the variable min and its position to min pos, we are going to traverse the remaining elements that are present in the array. So if this is the array at the beginning and this is the minimum number at the beginning, we'll be traversing through the remaining numbers of the array, and we'll be finding any number which is even lower than the current minimum number. So if min, which stores the current minimum element, that is AI, if it is greater than AJ, that is if we find a number which is even lower than min, we store it in min, and its position is recorded in min pos. Alright, so if we find any number which is even if we find any number which is even lower than min, we store its value in this min variable, and its position in min-pos, and after that we swap their positions. So like in this example that we have already studied, so here in this example 64 is initially considered to be the minimum number, and after that, after traversing through the remaining elements of the array, we find that 11 is the minimum number. So the positions of 11 and 64 are interchanged. In the next step, the positions of 12 and 25 are interchanged, and like this it will go through the entire array until and unless it is fully sorted. And after this selection sort algorithm finishes its task, we will be printing the sorted array. So when we invoke this sorted array function, it goes to this one, and it takes the array itself as the parameter, followed by the total number of elements that we are going to be entering into the array, which is represented by n, and then it prints all the elements of the array, and it will be giving a gap of 3 between each subsequent elements. So if we had just simply used %d instead of %3d, the elements would have appeared next to one another, and they would have looked really really kind of unorganized. And to eliminate such issues, what we are doing is we are providing %3d. So if we, instead of %d, simply using %d, if we choose to give %3d, all the elements will be printed with gaps of 3 from one another, and thus they will look a lot more tidier and lot more organized, and it will be easier for us to see what's going on and understand the steps. So let us execute the program and see what happens. So I think we have missed a bracket here, so let me run it once again. So I'll be selecting the first option, and we'll be giving 5 elements. So I'll be randomly entering 5 elements. So before sorting it looked like this, and after sorting this looks like this. So this concludes our tutorial on selection sort, and we'll be studying other sorting algorithms in the upcoming classes. So that's it for now, and I'll see you in my next video. Take care guys, and have a nice day.